Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your chemical explosives. In chemical explosive, we are going to discuss about the introduction. Okay, uh, and after that we are also discuss some other topic. Now, first of all, we have to know that what is the meaning of these words, that is the chemical explosives. Simply, the chemical explosive means that chemical that can react to that can react to produce gas at a gas at high temperature, and this gas is harmful, or you can say that it can damage the surrounding. Okay, simply this chemical explosive are what they are, the chemical, and when these chemical are reacted, they produces a gas, and this gas are what? This gas are produced at very high temperature, and this gas ultimately affect the surrounding, like it also cause a health effect to the human being, and also become a drastic for the animals and the environment, like create a pollution, these air pollution, water pollution. So ultimately it will damage the whole surrounding environment. Now let's start the today's lecture. Explosive, a chemical compound or their mixture that rapidly produce a large volume of hot gases when properly initiated. See, they are explosive or what? They are a chemical compound that I already told you. The chemical explosive or what? They are a chemicals. They are what? They are a chemical compound or even the mixture of the different chemical compound which produces a large number of hot gases. And these hot gases are what? They are they are harmful for the surrounding, and when these hot gases are produces when they are properly initiated. Explosive are known to denote at the rate of kilometer per second. Okay, so these explosive are denoted as a rate of kilometer per second, means that suppose 1 kilometer per second. For example, like it means that the chemical travel around 1 kilometer within a 1 second. Explosive are capable of exerting sudden high pressure, generating loud noise, and more or less destructive type of reaction. Now these explosive are capable of creating some different thing, like your maybe the pressure will increases, and these pressure are what? Suddenly these pressure are increases, and also generate a loud sound, that is called noise pollution, and some destructive type of reaction which is produced either by a mechanical, chemical, or nuclear explosion. A mechanical explosive are totally depend upon a physical reaction. Okay, and these physical reaction are what? That is your overloading a container with compressed air. Such a device has some application in mining, in which the release of the gas from a chemical explosive may be undesirable. Okay, so sometimes these explosive or what, they are undesirable and otherwise is used very little. A nuclear explosive is one in which a sustained nuclear reaction which can be made repeatedly, and this will create releases a large amount of energy. Chemical explosive account for virtually all type of the explosive applications. Now the next is your the destructive effect of explosive are much more spectral than their peaceful uses. But it is appear like that if there is a more explosive, then it have been used by our industries for a peaceful purpose, that in all the wars. But the destructive effects are always it is not acceptable, it is not peaceful. But sometimes if it is explosive have appear more, then it can be used by a industry for their purposes in different type of the wars. Our discussion futures of the explosive is the rapidity with which the chemical decomposition proceed into a unreacted body of the explosive. Now, these solid explosive are what? They are a chemical compound, and the mixture of the chemical compound which is initiated by the energy, and these energies are in a different form, like sometimes it is occur in a shock form, impact, heat, friction, spark, and also undergo a chemical decomposition reaction. And this chemical decomposition reaction, they are very fast. The decomposition usually take place during the absence of any external supply of oxygen, or even the absence of the oxidizer. Okay, so when that chemical decomposition take place, it usually take place during the in the absence of the external supply of oxygen. At that time there is no external supply of the oxygen are there, or absence of the oxidizer, then this reaction releases a large amount of heat and gas, which is used to perform a work in the surroundings. Now the next is the production of explosives have increased in the last decade. If we take a data of 2002, then in that case around 2.5 million metric tons of explosive are produces in US. Then 6% are higher than 2001. Okay, so in 2002 we can say that around 2.5 million metric ton explosive are produces where in US. And this data, if we compare this data with 2001, then there is a 6% increment. Now, coal mining with 68% of the total consumption was the dominant use of explosive in the United States. Okay, so coal mining contributed around 68% of the total consumption, in explosive in United Kingdom. Now, there is a figure which we'll discuss in a further slide, which shows that how sales for a consumption of the United States industrial explosive have changed since 1993. Now, 1993, there is a drastic change in a consumption sale for a consumption of US industrial explosive, which we discuss in a next figure. Development of the explosives. Among the important explosive material, black powder, that is known as a gunpowder, which is most likely the first explosive discovered accidentally by the Chinese alchemist. Okay, so the first explosive was discovered by accidentally, and this is what? This is a black powder. Accidentally. Okay, this is what? This is a black powder, and this black powder are known as a gun powder. Black color powder is known as a gun powder, and it is discovered by a Chinese alchemist. Black powder were formed during the process of separating gold from a silver at low temperature. Now there is a process in which the gold are separated from the silver. Okay, the gold are separated from the silver, and this separation are take place at very low temperature. Okay, now during that process, this black powder, that is also known as a gunpowder, are formed. Then potassium nitrate are added, and along with potassium nitrate, sulfur are also added into a gold ore in a furnace, and they forget to add a charcoal to the mixture. However, they added the amount of charcoal at the last step of the reaction. See, there is a process of separation of the gold from the silver. In that process, the potassium nitrate and the sulfur are added into a gold ore inside the furnace, and along with it, the charcoal mixture of the charcoal was also added into the mixture. But when they are doing these experiment, they forget to add the charcoal into the mixture, and they added the amount of charcoal at the last step of the reaction. In that way, they produces a black powder that is called a gunpowder. As a result, black powder was formed, causing a strong explosion. When this black powder are formed, then it caused what? It caused a strong explosion. The black powder was then introduced in the market as a mixture of potassium nitrate, charcoal, and a sulfur. When this black powder are introduces into the market, and when it is introduced into the market, they will introduce like a mixture of the potassium nitrate, charcoal, and a sulfur. The composition and the order of addition determine the properties of this composite explosive. Black powder contain a fuel and an oxidizer. So in black powder, fuel and an oxidizer are produced. The fuel is a powder mixture of the charcoal and a sulfur. Fuel is what? Fuel is the mixture of the charcoal and a sulfur, but it is present in the powder form, and as a oxidizer, potassium nitrate are present. Black powder was successfully introduced for blasting in 1627. The use of the black powder then spread fast for a mining, road building, and recovering ore in copper mines and other important industrial applications. See, this is the sale consumption of the United States industry explosive, and it is taken by an institute of maker of the explosive. You can see that here 1993, 1994, 1995, 96, 97, 98. There is a large number of sale consumption of that industrial explosive in United States take place in 1998. Then again in 1999 it will decreases, then increases in 2000, then again decreases, and then again increases in 2002. Okay, so this part are represented as a coal mining. Then the black part are represented are coiling and a non-metal mining. This one, this. Okay. Then metal mining is represented by this one. After that, construction work are represented by this one, and the other uses are represented by this one. So each, like this graph, each part represented some different thing. Like the lower part represented the coal mining, then above it it is a quarrying and the non-metal mining, then metal mining, then construction. No, yeah, then metal mining, then construction work, and then the end is other uses. So it represents the 1,000 metric ton or sales for a consumption of the United States industrial explosive. Then the limitation of the black powder as a blasting explosive were apparent for a difficult mining and tunneling operation. More efficient explosive were required. Then in that case, the liquid nitroglycerine was discovered by a Italian professor Subrero, was later studied and manufactured by a Swedish inventor Emmanuel Nobel in 1863. Then the major problem that the Nobel family faces during the transportation of that liquid nitroglycerine, which causes a lot of loss of life and the property. See, there is a limitation of the black powder, and this limitation is what it is, as a blasting explosion were apparent, and it is very difficult for a mining and a tunneling operation. but the most efficient explosive were required. Now, by Italian professor Subreron, they discovered for liquid nitroglycerin, and then after that they studied and manufactured this liquid nitroglycerin are manufactured and studied by a Swedish inventor Emmanuel Nobel in 1863. But they face a problem related to the liquid nitroglycerin, and this problem are related to the transportation, which created a loss of life and properties. Then the destruction of the Nobel factories in 1864 was one of the many accidents caused by a explosion of the nitroglycerin. Now, in 1864, the Nobel factories are destroyed due to the lots of the accident which are caused by a explosion of the nitroglycerin. Now, next is your the discovery of the mercury fulminate by Alfred Nobel in 1864. They improved the initiation process. This chemical complex are then replaced by a black powder in the initiation of the nitroglycerin in a bore holes. Then the major explosion are take place in 1866, which have completely destroyed the nitroglycerin factory. Alfred Nobel had discovered the safety hazard of the nitroglycerin during the transportation. But he reduces the sensitivity of the glycerin by mixing it with the absorbent clay that is known as a Kiesel Gur. See, when this nitroglycerin are transported, then it will cause damage to the human's life and the properties. Now, Alfred Nobel discovered this different safety hazard which is related to the nitroglycerin during the transportation, and it reduces the sensitivity of the nitroglycerin. And how he reduces that sensitivity? By mixing the nitroglycerin it with the absorbent clay which is known as a Kiesel Gur. Now the next is your the chemistry explosive was very active at that time as a nitroglycerin was introduced. Okay, so at that time the chemistry of the explosive are very active because the nitroglycerin was introduced. Nitrocellulose, which is also known as a gun cotton, was produced by the direct nitration of the cellulose. Okay, suppose that this is your cellulose. If this cellulose have a direct nitration, then it will produces a nitrocellulose. And this nitrocellulose are known as a gun cotton. The discovery and the use of the nitrocellulose was totally associated with the name of the two scientists, that is Schonbein and Böttcher. Now the synthesis of the nitrocellulose was extremely difficult and many accidents took place. That is, the destruction of the manufacturing plant take place in France, England and the Austria. And also the stability of that nitrocellulose was improved by the different process that is called a pulping, boiling and washing. Now in 1868, a dry compressed, highly nitrated nitrocellulose was discovered. In 1868, dry, compressed, and highly nitrated nitrocellulose was discovered, which is denoted by using a mercury fulminate detonator. Wet nitrocellulose could be exploded by adding a small amount of dry nitrocellulose. Then there is an interesting discovery was made in 1875 by Alfred Nobel when an explosive gel was formed, and this explosive gel are formed when he mixed nitrocellulose and a nitroglycerine. They are what? They are a explosive gel. They are what? They are nitrocellulose and the nitroglycerine. This gel was then converted in 1888 into a gelatin dynamite and ballistyle, which is known as a first smokeless powder. Ballistyle was in fact a mixture of the nitrocellulose, nitroglycerine, benzene, and the camphor. These explosive properties of that dynamite was improved by the Swedish chemist Olsen and Norbin. Norbin and Olsen, what they do, they improve the explosive properties of the dynamite by adding ammonium nitrate into it. This ammonium nitrate are considered as a hazard and the explosive until a disaster accident took place in 1947 in the harbor of Texas cities in SS Grand Champ and the SS High Flyer, both loaded with a fertilizer grade, that is the ammonium nitrate. Now the next is your commercially explosive were very attractive, especially in a coal mining. This black powder was mainly used in a coal mining. However, many disaster explosion occur. Then this attempt are modified and the modification are take place in case of the black powder. This black powder are mixed with a cooling agent like your ammonium sulfate or a paraffin, and it is not very successful. There is a development of the dynamite and the plastic gelatin, and it is done by a noble placed nitroglycerine, which is totally based upon the explosive at a position where they could dominate the mining industry. Then after that, the government prohibit that mining industries, and eventually some government also prohibited the use of the explosive in a coal mining operation, owing to a potential increase in dust and gases. After through a study and the various experience in an explosive, the different materials were recommended for the use in the production of the explosive for a coal mine. These materials were mostly based on a ammonium nitrate, and this dynamite and a black powder are failed the test set for this purpose, and then it is replaced by a ammonia nitrate. Then the explosive or that passed the test were called a permitted explosive. There is the development of the military explosive, which is started approximately since the discovery of the black powder. Okay, so there is a development of the military explosive, which is started during the discovery of the black powder. Like in 1885, Turpin discovered a picric acid or a trinitrophenol 2, which is found to be a suitable replacement for a black powder. Now, there is a two discovery were take place in 1885, and this discovery was done by a Turpin. He discovered picric acid, that is also called a trinopropylphenol 2, and it is a replacement of the black powder. This is what this is your trinoprophenol 2. Now, picric acid was adopted all over the world as a basic explosive for the military uses. Then this picric, when this picric replaces the gunpowder, this were adopted all over the world, and it is used as a basic explosive for a military uses. Then the major problem of picric are corrosion of the shell in the presence of water and high sensitivity of its salt. Then this picric acid melt only at very high temperature. Then there is a two major problem which are related to the picric. One, this picric are melt only at very high temperature, and the second is that the picric acid are corrosion of the shells in the presence of water. When the water are present, then the corrosion occur, and it is very high sensitivity uh, of its salt. Tetrail 3 was discovered at the same time as a picric acid. Tetrail was first time used as an explosive in 1906. When the picric created a problem, then at the place of this picric, then tetrail were used, and it is discovered at the same time when the picric acid are discovered. Now the next is, now in 1863, Wilbrand prepared a trinitrotoluene 4, that is also called a TNT4, for the first time. TNT was prepared in pure form in 1880 by a HEP, and the structure was established in 1883 by a Clamps and Beaker. See, TNT was prepared by a Wilbrand in 1863. Then the first time the pure TNT4 was prepared in 1888 by a HEP, and the structure was discovered by a Clamps and the Beaker in 1883. Now the TNT was adopted for the use by the German army in 1912 by the US Army. German army adopted TNT in 1902, and US army adopted it in 1912. The storage of the TNT was made easier by the use of the mixture of the TNT and the ammonium nitrate, which is known as a amatol. When TNT are mixed with ammonium nitrate, then it is called a amatol. After World War I, research in the area of explosive was concerned, which are treated on the development of the new and more powerful explosive material. Like, for example, cyclotrimethylene, trinitramine, which is known as a RDX-5, and the pentyl tritol tetranitrite, which is known as the PETN6, were among the newly discovered explosives. This is a table which shows the examples of the PBX composition, like HMX, that contain cyclotetramethylene tetranitramine octogen, HNS, that is your hexanitrocetylene, PETN, that is your pentaerythritol tetranitrate, RDX cyclotrimethylene trinitramine hexogen, TATB 135 triamino 246 trinitrobenzene. And this source was taken by our Chemistry of Explosives, second edition, 4th. RDX was discovered by the German scientist Henning in 1899, and the purpose behind the purpose behind the discovery of the RDS is what? Medicinal use. Now it is used as a good explosion in 1920 by a Hertz, in a higher yield by a Hale in 1995, by a Buckman in 1940. PETN6 was discovered in 1894, and it is obtained by the nitration of the pentyl tritol during the World War II. RDX were used more than the PETN, and the mixture of 50% of PETN and the 50% of TNT was developed, and it is used for a foiling hand and anti-tank grenades and the detonators. Another class of the explosive known as a polymer bonded explosive, that is also known as a PBXs. PBXs, that is called a polymer bonded explosives. It is discovered so that it will reduce the sensitivity of the explosive crystal, and how it is reduces by embedding them in a rubber-like polymers, that is known as a polystyrene. Polymer bonded explosive are totally based on a RDX and the RDX PETN, and also known as a HMX were developed. Energetic plasticizers have also been developed for a PBX production. Now this table give an example of the energetic polymers, their common name, their chemical name, and their structure. Glycine, that is monomer, and the chemical name is glycidyl nitrate. Polyglycine, polyglycidyl nitrate. Nimo, 3-nitromethyl 3-methyl oxetane. Polynimo, poly 3-nitromethyl 1,3-methyl oxetane. GAP, glycidyl azide polymer. Ammo, 3-azidomethyl 3-methyl oxetane. Polyammo, moly 3-azidomethyl 1,3-methyl oxetane. Bamo, 3,3-bis azetomethyl oxetane. Polybamo, poly 3,3-bis azidomethyl oxetane, and the structure are also there. Research and development is continue in the chemistry of the explosive, so that it will produces a compound that are insensitive to a accidental initiation, but is still highly effective in case of the explosive. NTO7, ADN8, and TNAS9 are the good example of that explosive compound which are under development and testing. So these are the structure of TTO, NTO7, that is called a 5-nitro 1,2,4 triazole 3,1 ADN ammonium dinitramide, and TNAS9, that is 1,3-trinitro So this is all about the introduction of that chemical explosive. I hope you will understand, but if you have any query related to this topic, you can ask me in a comment box, or for a further detail you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.